All right, so now we're going to move on to the solving radical equations. So it was 2r minus 2 is equal to the square root of 8. So remember, once our first step is to isolate our radicals. Well, these are both isolated, so we will just square each side. And when we square each side, because our index is 2, they cancel out our radicals, and whatever is on the inside just comes out. So it's equal to 8. We'll add over the 2. So 2r is equal to 10. Divide by 2. So r is then equal to 5. All right, the next one, we have the square root of a plus 6 is equal to the square root of 6 minus 9a. Once again, they're both square roots that are isolated, so we can just square it because our index is 2. So we raise it to that power. What we do to one side, we have to do to the other. So these cancel out or eliminate or undo our radicals. So it's just a plus 6 is equal to 6 minus 9a. All right, so I will then add over this 9a. And I will then subtract over this 6. Now when we do that, a plus 9a is 10a, and this over here will equal to 0. A lot of you guys have started saying that 10a is the answer. It's an equation. The equal sign just doesn't go away. And then we would need to divide each side by 10 to isolate that a, and a is equal to 0 because 0 divided by any number is 0. So a lot of you guys wanted to say that there's no solution. That's not the case. The answer is 0. If we plug it in, 0 plus 6 is 6, so it's the square root of 6. 6 minus 9 times 0 is 6, so it's the square root of 6, and they are equal. All right, the next one, it was the square root of negative 5 minus x plus 4 is equal to 6. So remember, step 1 is we need to isolate our radical. So if anything's being added, subtracted, multiplied to the outside of the radical, that needs to be, we need to undo it. So to get rid of this plus 4, we need to subtract 4. So now we have isolated the radical all by itself. We can't subtract the 4 from this negative 5 because this radical is considered a parentheses. We need to do everything on the outside of it. And now remember, to get rid of a radical with the root of 2, we need to then square it. And what we do to one side, we have to do to the other. So this will undo the square root. So it's minus 5 minus x is equal to 4. And then we will go ahead and add over the 5. So negative x is equal to 9. But we want to solve for a positive x, so we divide each one by negative 1, and x is equal to negative 9. All right, the next one we have the square root of x over 6 minus 2 is equal to 1. So remember, we isolate our radical first. This divided by 6 is inside the radical, so we can't get rid of that divided by 6 until after we get rid of the radical. So we need to add over this 2 first to isolate our radical. So it's the square root of x over 6 is equal to 3. Now we will go ahead and square both sides. So it's x over 6 is equal to 9. That's what 3 squared is. When we x over 6 or the fraction, that means division. So multiplication will undo our division. So 9 times 6 is equal to 54. So our x is equal to 54. All right, and then the last question we have for this problem or this set of problems is the 3 times the square root of 2x plus 1 minus 5 is equal to 19. So we need to isolate this radical. So there's multiple things that are being done to this. One, we have this minus 5, so we need to add 5 to both sides. All right, then we still have not isolated this radical because we still have the 3 being multiplied to it. So we need to undo the multiplication of 3, so we divide each side by 3. So we're left with the square root of 2x plus 1 is then equal to 8. And now we need to get rid of our square roots, so we will square it because our index matches a power. They eliminate or cancel each other. So then it's 2x plus 1 is equal to 64. So let's just rewrite this over here. So we have 2x plus 1 is equal to 64. We will then subtract over a 1 because now we're just solving for that x. So 2x is equal to 63. And then we divide each side by 2. X is equal to 63 over 2 or 31.5. All right, and that is it for this section.